Hi everyone. In this video, we are going to solve one more problem. The problem name is shortest path with alternating colors. And the problem number is 1129. Let you please see first of all what this problem says. After that, we are going to see the logic part, how we can solve this particular problem. And at the end, we are going to implement our logic. So, you please see this. You are given an integer n, the number of nodes in a directed graph where the nodes are labeled from 0 to n minus 1. So, right, we are given with the graph where n will tell us that how many nodes we have inside our graph. If n is 4, that means we are going to have 4 nodes in our graph. So the label are going to start from 0. That means the first node will have label 0, second node will have label 1, the third node will have label 2, and the last fourth node will have label 3. So label are going to start from 0 to n minus 1. Each edge is red or blue in this graph, and there could be self edges and parallel edges. So let's make a graph first of all. Let's say this is a graph, and we are going to have some directed edges. Now, guys, it says that we can have a parallel edges. That means we can have more than one edges between two. 0 to 1. Right now we are having only one. We can have more than one edge. This is nothing but parallel edges. We can also have a self edges. That means self 2. From 2 we can come again to 3, we can come again and again and again and so. So these are going to be self edges, right? So all right, now guys, they are saying that each edge is red or blue in this graph. So they have specified the color of an edge. What does it mean? Let's say we have this node 0 1. Let me move all the edges. Fine. Now guys, we can have a red edges they have mentioned or blue edges, right? So let's draw some red edges 0 to 1 and 2. Fine. We can also have a blue edges. 0 to 2 we have one blue edge. Let's make some parallel edges. All right. Now, guys, this is that we can have either red or blue edges inside our graph. Fine. So these two things are clear. These two lines are clear, I hope. Now, guys, you are given two arrays, red edges and blue edges arrays. And I guess, guys, if you know graph little bit, then you must know why they are given these two arrays. So we know that 0 to 2 is the graph, right? 0 to 2, there is a path. From 0, we can go to 2, right? But how will we come to know that from 0 to 2, which color of edge we know? That will tell us by this particular array. If 0 comma 2 is present inside of blue edges array, that means we can say that 0 to 2 there is a blue edge. If 0 comma 2 is present inside of red edge array, that means we can say 0 to 2 there is a red edge. I hope this much is clear to you. And here guys, you can see that we are having 2 to 3 there is a red edge array. That means 2 comma 3 must be present inside of red edge. And same note 2 comma 3 2 comma 3 can be present in both red edges and blue edges array, right? And you can see that 0 comma 1 is must be present inside of red edges and blue edges array, right? And there is not a limitation. Particular edge also can be present multiple times. 0 comma 2 can be present multiple times in red edges array, blue edges array. All right. Now, guys, return an array answer of length n, where each answer is the length of shortest path from node 0 to node x. So now, guys, we are going to return an array of same size of length n. So here n was 4 because we are having a level from 0 to 3, right? So here we are going to return an array of 4 size. Fine. So this is going to be 0 index, 1 index, second index, third index. We have to return the length of shortest path from node 0 to node x. Guys, think about this. Our source node is clear 0, right? They have mentioned from 0 node, right? To the respective node x. And x is nothing but iterable. X will go from 0 to 3. Right? So first thing is going to contain the shortest path from 0 to 0. This thing is going to contain 0 path from 0 shortest path from 0 to 1. And this particular thing contains 0 to shortest path. 1 0 to the shortest. Alright, so this much is clear, I hope now. But there is a condition. We can't take that particular path where we have a two adjacent edges same in color. I can say, let's say there is a, let me take a different color. If I have this 0 to 1, if I'm taking a 0 to 1 red color, again I have to take another edges that should be different from this red color. I can't take red color again and again, right? I can't take two adjacent sides, same color. I have to take a different color. Means alternate the color. That's what the question says. Shortest path with alternating the colors. You have to take such path where your color are not having the same color. Your color are not same in adjacent side. So here are, then here should be blue, right. Again, you have to take a red. You can't take blue, right? This is the what the concept, or we can say the main problem inside of this problem. Now, guys, if there is a node path exist, means you can't go from 0 to let's say here 3, then on that place you have to insert -1. And after that, once you completed this, you have to return this particular array. So this is what the problem says. And this is a medium level problem. I guess you must know what is the problem. You must have a clear idea about this problem. All right, now how we can solve this particular problem? Think about this, how we can solve, what is the logic we can solve it. For that, let's take a first example here. They mentioned the first example and how does this answer come. You must have a clear idea because after that we are going to discuss about the logic, and for logic For understanding the logic, you must have a clear idea about the problem. So here inside of this first problem, we have n is equal to 3. Right? If n is 3, that means we are going to have 0, 1, and 2 nodes. And after that, they are given us some red edges array. So we have something, we have two values in red edge array, that is 0, comma 1 and 1, comma 2. 0, comma 1 means we have a red edge between 0 to 1, comma 2. We have red edge between 1. And there is no blue edge exist. Blue edge array is empty. Fine. Now guys, we have to return an array. So we have to return an array of same size n, that is 3. This is 0 index, this is 1 index. Now guys, find out the shortest distance from 0, source node 0 to 0. That will be placed here, right? Shortest distance will be 0, right? Because we are standing there only. Now from 0 to 1, from 0 to 1 you can see that we can take simply this edge. Need to take just one edge, we can reach to 1. Because there is only one edge, so there is no need to check the concept of alternate color, right? Now we need to reach at second index from 0. Think about this guys. We can take the first and this particular edge, reach to 0 to 1, right? So we can say, let me remove all these things. We can say guys, we reach from 0 to 1 with the color of red, right? We took a red edge. Next time I need to take a blue edge, definitely. So I have to find out the edge from 1 to 2, which is on a blue color, but there is no edge exists with blue color. Definitely I can't go from 1 to 2, right? So we are going to return here minus 1. After that, we are going to return this edge. You can see that in the output also we have 0, 1, and minus 1. Now guys, now I believe that you must have a clear idea about this problem, what this problem says, and what we have to do in this problem, how we can solve this problem. Let's discuss this. I'm going to scroll. Let me scroll. And I'm going to take an example where first time I submitted my code, I got a wrong answer, and the example was this, and was 5. We are going to have, let me write here 5 nodes, 0, 1, 2, 3, and it will go to 4, right? Because n is 5, 0 to n minus 1. Now guys, we are having some red edges, 0 to 1, 1 to 2, and we are having some blue edges as well, 1 to 2, 2 to 3, and 3 to come back to 4. This was the graph which was given. Now guys, here we have to find, we have to return a array of same size and 5, right? This is 0 index, 1 index, second index, third index. Fine. Now we have to return the shortest path from 0 to all the others node, right? Now how we can do this? Just tell me one thing first of all, which algorithm you use to find the shortest path? If you know a little bit about graph, we use BFS, right? Same BFS algorithm we are going to use in this problem, but a slightly change will be there. The changes will be about color. So let me first of all, we are going to insert in our queue, this is a 0 level. Okay? Instead of a 0 level, first of all, we are going to say we are standing at 0, right? This is a 0 level, and I'm going to draw some levels. So this is going to be 1 level, going to be second level. Let me draw 7 levels because I know that what will be the answer. 26, 87. All right, this is the fine. Now, guys, what I'm going to say initially we have 0, right? We're going to start from 0, and the color we can say here is nothing but minus 1. Minus 1, why? Because we can say here at 0, we can take any color. We don't have any restriction right now, right? So minus 1 will indicate that no color, haven't taken any color. 0 will indicate that we have taken a red color earlier, and 1 will indicate that we have taken a blue color earlier. Fine. So 0, we have minus 1, right? You can write here like this. So come on. Now we are going to pop this particular level. We are going to pop all the elements from this level, and we are going to insert all the adjacent nodes which satisfy the condition. So we are going to pop it 0, 0 we can go to 1. So I write 1. And can I take 1 first of all? Check it. 1, for taking 1, we need to take a red edge. And I have minus 1, so I can take any edge, right? I can say I come to 1 with a red edge. 0 indicate red edge. And I can't go any other nodes because there is only one node is connected from 0 which satisfy the condition. Now we are at 1 level, but before that, once we are popping 0, we know that this particular node is going to be inserted in our resultant array. This is resultant array, and by default they all have minus 1. So on 0, I have to put this particular level. Alright, now at one level, I'm going to pop all the nodes. So this has done. So I can mark a tick. Now this is I am going to pop all the nodes. So this node, first of all, I'm going to pop this. So I can see that the node is 1, and 1 will have nothing but this one element. On the index of 1, I'm going to set the level. So 1 is nothing but 1, and 1 was having a red color. So I have to take a blue color. Find out all the connected nodes which are connected to 1, which have a blue edges. You guys can see that 1 to 2 we have one blue edges, right? So we can take 2, right? We are going to 2 with a blue edge. So blue edges is indicated by 1. Fine. And is there any node exist between Here we can go by the one with the blue edges. There is no node exists. We are going to just end up with like this. We have taken all the nodes from level 1. Now we are coming to 2. So let's pop all the nodes. So there is only one node, so let's pop it 2. But before that, once we are popping, we have to write something on the index of 2. That is nothing but level number. Level number is 2. I'm going to say on index 2, I'm going to write 2. And the color I come by the blue color. Now I have to take a red edge. So is there any node connected with 2 have a red edge? You can see that 2 to 3 we have a red edge. Right? There is a red edge also present. We can take 3 which come with a red edge. Now we come to the third level. Second level also completed. Third level we are going to pop only one element there. So we are going to pop it. But first of all on third index we are going to write this level. That is 3. So this is just a consequence that we are coming up with the same level. But right now you will see in later on that how the level are changing. So 3 comma 1. So we inserted on the third index this level. Now we have to find out all the nodes which are connected to 3 which has not already been taken and have a different color from this. They are come with the red colors. We are come with the red color. Let me write here red. We have to find a blue edge, right? So there is a one node connected with 3 that is 4 and there is another node connected with 3 that is 1, right? There are two node connected with 3. You can see there are two edges. But we can't take 4 because 4 is connected with the red edge. We have to take the edge which is different from this. We have come up with the red edge, so we can't take again a red. We have to take a one edge, right? Means we can take only one that is connected with blue. So I can insert again one and with the blue edge. That means I come up with the fine. Now this one is also done. Now we are at fourth level. Pop all the elements. We pop it one. So write on one index what level 4. So on one index I have to write 4. But don't you think that I am not taking a shortest path? We can say guys, you have to update this thing only when you can see there is no minus 1. Here if there was minus 1 that means we can update this value. But here if there is not a minus 1 that means we have already taken the shortest path. We are not going to update it, just we are going to pop it, right? We pop 1 and we can see from 1 we can go to 2 as well, right? But we have taken a blue edge earlier, so we can take only red edge. You can see we have a red edge with 2. Yes, we have red edge, so then we are going to take 2 red edge. 2 comma 0. And you can see we are taking a 1 edge again. Let me You can see that guys we have taken already 2 with a blue one, so we can't take it with blue only. If there was red again we can't take it same as again. We are going to maintain a set as well. So here you can take once as only one time in your graph, in your problem, we can see in your algorithm as well. So here 2 comma 0 that was not taken earlier, so we take it again. Now we are at 2. Pop it this element. So once we are popping it we are going to update it, but there is already something shortest path present at second index, so just we are going to pop it. Now once we pop it we are going to check it what are the adjacent nodes are present with 2. Where we can have a different color which has come by zeros. We have to find a red colors. Here you guys can see that on second index. Let me find out here this. We are come with 2 with this particular color, red color, right? Now we have to find a new edge, means new connected node with a different blue color, right? Is there any node present with a 2 which have a color blue? Just find out. Yes, there is a node present 3. Now this we are going to take because this contain a blue edge as well, right? We have taken a red edge, but we haven't taken a blue edge, so we can take 3 comma 1. All right. Now we are going to pop this one as well. We are at 7 level 6. We are not going to update 3 because we have already shortest path present. So is there any node present with 3 has a color red? Yes, there is a node present with 3 that is 4 which has color red. So you can write here 4 and the color is nothing but guys red. That means 0. Now just we are completed 6 level. Come to 7 level. Pop this particular level as well. So find out is there any node connected with, but before finding out you have to, what you have to do, you have to update the index. At 4 index you have to update this particular level, and you can see here the value is -1. That means we haven't calculated the shortest path right now. We can say here the answer is going to be, and we have to find out all the adjacent node which are connected to 4 which have nothing but the color blue, right? There is no node present with the 4, so we can say we are not going to insert anything in our queue. We'll come up with a new next level, that is 8 level. But here you can see our queue is empty. Once our queue is empty, what we are going to do? We are going to break our loop. And once we break our loop, we can see that we have already calculated the all possible shortest path from 0 to all other nodes. We are going to return this particular result. I know this is a little complex, but just try to understand this. If you're still not getting it, go back, then try to watch this again. I will definitely say that once you dry run your code 2 or 3 times, you will definitely get an idea how this code is going to work. First of all, we have to move to the code and see how we can write this particular logic and how we can write the code. Right? Let's move to the. So here, guys, let me increase the size. I hope now this much is visible to you. Now, guys, what we are going to do? We are going to say, let me write here. First of all, what we are going to do? We are going to create an adjacent list, right? So I'm going to say I'm going to create an adjacent list. So how you can create in Python? First of all, you have to mention. Let me write here first. Of all, and here I'm going to say adjacent list is going to be empty for every node right now. So for every node, I'm going to say adjacent list is empty for I range of n. Fine. Now, guys, for every node it is empty. Now I have to fill it the adjacent list, all the possible path from zero node, one node, all the nodes, right? I'm going to say first of all I'm going to fill the red edges. I'm going to say red edges for a comma b in red edges. I have to say adjacent list of a. You have to append it b. But here we can't append only b. We have to append also b comma 1. Not 1, 0, because we are indicating that for 0 for red edges. If there is a 0, that means this is a red edge, right? And same are going to be do with the blue edges. So I'm going to say blue edges for a comma b in blue edges. Let me write. Here we are going to say adjacent of a dot append b comma 1. 1 is for blue edges. We are getting a 1, that means that is blue edge. I have this much is clear to you. Now we have filled our adjacent list. Now it's time to use a BFS, right? For BFS, what we are going to do? First of all, we have to maintain a resultant array, right? And by default, we are going to put -1. We have to say -1 into n. So we are having a resultant array -1. And after that, we are going to use a queue. So queue is going to have initially what? We are going to pass 0 with a -1 value. -1 means there is no color, right? And after that, we are going to use a set. It's listed. So this set is going to contain something. So this set will say what we can contain. We can contain a nodes, right? We can say this set is going to contain something that is nothing but node. So we can write here we have already taken 0 with a -1. I hope this much is clear to you. So we can't take a same edge again inside our BFS. So we have maintaining a set. If this edge already taken, we are not going to proceed with that particular, right? All right. So now let's use a BFS. We are going to say while queue is until and unless we are not empty with the queue, we are not left with any element. Don't break it. If we got empty, that means you have to break the loop. Fine. And every time we have to pop it. So we are first of all we have to mention the level as well, as I have told you in the graph as well how I did it. The level initially was 0. Now we are going to say we have to use us find out the size. So size is going to be length of, because we have to pop all the elements in the inside of level. So we are going to say for I in range of size means just pop all the elements of that particular level. So for that level, what I'm going to do, first of all, I'm going to pop it. For popping it, I'm going to say front node is going to be node to be q dot pop level, right? Fine. Now once we pop that particular elements, let me make it size bigger. Now once we pop it, we have to check it whether that particular node, if front node of 0 means that particular node is, we have a -1 inside of a result. So we can say result of that particular node is -1. That means we can say we are not going to update. But if it is a -1, that means we have to say that update the shortest result over there. So we can say result of front node 0 is going to be 11. Fine. If it is not the case, then don't need to update, right? After that, what we can say? We can say find out all the adjacent. So for child node in adjacent of that particular front node of 0, you have to find all the child nodes, and you have to check first of all if that child node, I can say if child node 0 comma child node 1 is present already in my set is visited, then don't need to do anything. Just continue it. Don't want to take same edge again, right? But if it is not present, then you have to take it. But before that, also you need to check one more thing. Child node of 1 is the color code is different than the our, you can say front node. You pop it, then you have to take that particular color. Otherwise, don't take. If you're taking it, then you have to update in your set. So we can say is widget dot add. Yes, you can say this particular. Let me copy quite easy. You can say just add in our set. That means we have taken that particular edge, and after that you can say insert in our queue as well. So queue dot append that particular child node of 0, and we can say child node of 0 and child node of 1, right? Child node of 1. Right. Once we are done with this, now what we can do, we can say we can insert it here. Like I haven't done this, so I have to do couple inside of DQ. I'm taking a two thing inside a list, right? Now guys, once we have done with this, we are going to say level plus plus, right? Once this loop will done, so we are going to move to the next level. I hope this much is clear to you. Now once we updated the level, at the end when our queue will be empty, our result will contain all the possible path which are possibles and all the shortest path, right? And at the end we can say return our result. Now let's find out, do we have mistake inside our code or not. For a comma b in red edges, we are doing all these things. We are size. It is -1, then update the levels. Otherwise, don't update it. And just use. Let's try to run this code and see whether we are getting any error or not. Yeah, there is an error front node. I have used a fourth node. I don't know why. And is there any? Let's see. All right. So you can see that case one and case two both are accepted. So let's try to submit this code and see whether it's get submitted or not. By the way, I have already submitted. I believe that it will get submitted. And yes, it is submitted, right? I hope this much is clear to you. If you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. And if you like this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.